Hi everyone, Top G Maths here. In this video, we learn how to do short division. Now, short division is simply a shortcut for long division. So if you don't know how to do long division, please watch my video on that before seeing this video. So the main advantage of short division is that it's much shorter than long division, as the name suggests. So instead of writing the numbers as columns down here, you would simply do your working out on one line. So that saves a lot of space. So we'll start with examples that give whole numbers. And then we'll do divisions that give terminating decimals. So things like 5.01, for example, that's a terminating decimal because it stops after the decimal point. And then we'll do examples that give recurring decimals. So things like 5.333 and then ... That's a recurring decimal because it doesn't stop after the decimal point. So let's start with an easier example, 84 divided by 6. So we lay out the division as usual, but this time we space out the digits slightly of this number. And you'll see why in a minute. And then 6 goes into 8 once with a remainder of 2. So instead of writing 6 over here and then subtracting to get the remainder, as with long division, you would simply write the remainder over here. And then you'd look at this number, and then you'd see how many times 6 goes into 24. So 6 goes into 24 4 times with no remainder. So the answer is 14. Okay, let's try doing 92 divided by 4. So we lay out the division as usual. 4 goes into 9 twice with a remainder of 1. 4 goes into 12 3 times with no remainder. So the answer is 23. Okay, what about 516 divided by 12? So 12 doesn't go into 5 this time, it doesn't go into the first number. So we consider 51 next. So 12 goes into 51 4 times, excuse me, with a remainder of 3. And then 12 goes into 36 3 times with no remainder. So the answer is 43. Next, we're going to do divisions that give terminating decimals. So for example, 49 divided by 4. 4 goes into 4 once with no remainder. So the remainder is 0. And then 4 goes into 9 twice with a remainder of 1. So at this point, you can either write the answer as 12 remainder 1. So that's how some schools teach it. You have to write the remainder and the quotient. And you can also carry on the division to get decimals. So to do that, you just add a 0 to the 1. And because this is the first 0 we're adding for the whole division, we'd put a point at the top. And then 4 goes into 10 twice with a remainder of 2. And then we add another 0 because 4 doesn't go into 2. And then we don't add anything for that 0 over here. So 4 goes into 25 times with no remainder. So the answer is 12.25. Okay, let's try doing 59 over 8 and 481 divided by 40. So 8 doesn't go into 5, so we consider 59 next. 8 goes into 59 7 times with a remainder of 3. And then 8 doesn't go into 3, so we add our first 0, and then we put a point at the top. Then 8 goes into 30 3 times with a remainder of 6. And then 8 goes into 60 7 times with a remainder of 4. And then 8 goes into 40 5 times with a remainder of 0. So the answer is 7.375. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. 3 7 5. Okay, 40 goes into 48 once with the remainder of 8. 40 goes into 81 twice with the remainder of 1. And then 40 doesn't go into 1. So we add our first 0 and we put a point at the top. 40 still doesn't go into 10. So we add a second 0 for this remainder. And then since we're adding a second 0 for the same remainder, we'd put a 0 at the top for that second 0. And then 40 goes into 100 twice with a remainder of 20. And then 40 doesn't go into 20, so we add a 0. We don't add anything at the top for that 0. 40 goes into 200 5 times with no remainder. So the answer is 12.025. Okay, have a go at these examples. 1 divided by 8, 41 divided by 400, and 401 divided by 80. So for the first example, we see that 8 doesn't go into 1, so we add our first 0, and then we add a point at the top. 8 goes into 10 once with a remainder of 2. 8 goes into 20 twice with a remainder of 4. And then 8 goes into 45 times with no remainder. So the answer is 0.125. So 400 doesn't go into 41, so we add our first 0, and then we put a point at the top. 400 goes into 410 once with a remainder of 10. 400 doesn't go into 100, so we add our second 0 for this remainder. And then we put a 0 at the top for that second 0. 400 goes into 1,000 twice with a remainder of 200. And then 400 goes into 2,005 times with no remainder. So the answer is 0.1025. Eighty goes into 401 5 times with a remainder of 1. 80 doesn't go into 1, so we go ahead and add our first 0, and then we put a point for that at the top. 80 still doesn't go into 10, so we add our second 0 for this remainder, and then we put a 0 at the top for that second 0. 80 goes into 100 once with a remainder of 20. 80 goes into 200 twice with a remainder of 40. And then 80 goes into 400 5 times with a remainder of 0. So the answer is 5.0125. Okay, let's try doing some divisions that give recurring decimals. So for example, 5 divided by 7. So there's actually a way you can tell that this will give you a recurring decimal. And the way you tell is by looking at the divisor and specifically the factors of the divisor. So if we go back to the terminating decimal examples, and we pick a random example, so let's say this one, and then we factorize the divisor. So we write 40 equals 2 times 2, and then 10 is 2 times 5, so that would just be 2 times 2 times 2 times 5, which can be written as 2 cubed times 5. Notice that the only factors it has are 2s and 5s. It doesn't have any other numbers as factors. I mean, it does technically have other numbers, so it has 8 as a factor, for example. That's not 2 or 5, but it's still only made up of 2s and 5s. So 8 is 2 times 2 times 2, for example. So if the divisor is only made up of 2s and 5s, we know it's going to be a terminating decimal. That's why this is a terminating decimal. If the divisor has factors other than 2 and 5, so 7 has a factor of 7, for example, that means it's going to be a recurring decimal. So let's do the division. So we'll write 5 over here. 7 doesn't go into 5, so we add our first 0, and then we add a point at the top. 7 goes into 50 7 times with a remainder of 1. 7 goes into 10 once with a remainder of 3. 7 goes into 30 4 times with a remainder of 2. 7 goes into 20 twice with a remainder of 6. 7 goes into 60 8 times with a remainder of 4. 7 goes into 40 5 times with a remainder of 5. And then 7 goes into 50 7 times with a remainder of 1. So from this point onwards, the remainders are just going to repeat. So we're going to get 10, and then this is going to become, so 7 goes into 10 once with a remainder of 3, and then it's just going to repeat from this point onwards. So it's going to be 1, 3, and then the next remainder is going to be 2, and then 6, 4, 5, and so on. So we know it's going to be a recurring decimal from this point onwards, and then we would just write the answer as 0.714285 recurring. So that just tells the reader that this is going to, these digits are just going to repeat after this. So it's just going to be 714285, 714285, 714285, and so on. Okay, let's do 567 divided by 11. So again, we can see that this has a factor that's not just 2 and 5, so it's got a factor of 11. So that means it's going to be a recurring decimal. So 11 goes into 56 5 times with a remainder of 1. 11 goes into 17 once with a remainder of 6. 11 goes into 60. Okay, so at this point, when we add our first 0, we need to put a point at the top. And then we carry on as usual. 11 goes into 60 5 times with a remainder of 5. 11 goes into 50 4 times with a remainder of 6. And then the remainders are just going to repeat. So that's going to be 5 with a remainder of 5, and so on. So it's just going to be 51.54 recurring. Okay, let's do one final example. 43 divided by 13. So 13 goes into 43 3 times with a remainder of 4. And then we add our first 0 and we add a point at the top. 13 goes into 43 times with a remainder of 1. And then we add a 0, don't add anything at the top. 13 still doesn't go into 10. So we add our second 0 for this remainder. And then we add a 0 at the top for that second 0. 13 goes into 100 7 times with a remainder of 9. 13 goes into 96 times with a remainder of 12. 13 goes into 129 times with a remainder of 3. 13 goes into 30 2 times with a remainder of 4. 13 goes into 40 3 times with a remainder of 1. And then it's just going to repeat from this point onwards. So it's going to be 4, 1, 9, 12, and so on. So we know it's going to be a recurring decimal from this point. And this is going to be the recurring part of the decimal. So it's just going to be 3.307692 recurring.